going to start with today is just going over a review of the connectors that we use. I know it's been a long time since we've talked about hardware, and I hope that you kind of remember some of this stuff. Mod 3 is all going to be about hardware and stuff like that, so it's good to get this review here at the end and kind of get going with stuff here. All right. Remember, if you have any questions, please chime in, please ask. Be more than happy to answer them. And for some reason, my chat stream keeps telling me, welcome to the chat room. So, right, we're off to a good start so far. All right, so basically, connector types. In each studio, you've got different plugs that plug into your mixer, your console. And there's two basic rooms that we have whenever you're in a studio. There's the control room, and the control room is where the engineer lives. That's where you're going to live. That's where you do all the mixing and stuff like that. And then you have the studio, and the studio is where the musician lives, where you're going to do the recording. That's where the microphones are set up inside that studio. And the way that we connect the two rooms together is there's cables that connect them. But obviously, the studio is one room and the control room is another room. So there's not any, you're not going to have a cable that goes from one to directly to the back of your mixing desk. Now, if you're in a home studio and you have a mixing console in your home studio, that might be different. You might have everything in one room, or you might have just a little mic set up in the corner, or you might have, you build like a little vocal booth inside of one room inside of another room. And in that case, you might have a cable that's going straight from one place to the next. But with these bigger studios, what you have is you have what they call a mic panel in the studio. So inside the studio, you've got a mic panel, and on that mic panel, it's going to have some designations of where each input is going to. You're going to have several different types of inputs on there. You're going to plug your cable into those inputs into whichever control room you're going to go to. At SAE, we have several control rooms, and a bigger studio will have several control rooms. Smaller studios will just have one control room. It just depends on the size of your studio. So if you have a bigger studio that's got multiple control rooms, on this mic panel inside the studio room, you're going to have labels, control room A and control room B, and maybe C and D. At school, at SAE, we have control room A, B, C, and D. So here it says control room A. You can see it says CRA. I know it looks like a P almost, but it's an R. And it says control room B here. And the control room A, if I wanted to go into control room A, let's say for example that control room A is the audient, and I want to go into the audient, I want to go to input channel number 3 on the audient. So what I would do is I would plug my microphone into control room A number 3 right here, and that's going to go into audient channel 3. If control room B is my O2R and I want to go into channel 5, what I would do is I'd plug the microphone into control room B port 5 right here. Right? And that's how that works. So you have that A and B here, and you just have to know which control room is which desk that you want to plug into. Okay. So there's two things you have to know when you're in the studio. You have to know which studio you're in, and you have to know which control room you're in as well. So those are the two things you have to know. Let's go to the next page here. All right. So the way this works here is control room A, number 1 here would go into channel 1 on this console here, and control room B, number 3, would go into channel 3 on this console here. Different consoles, different control rooms coming from one studio. So you can do like that. So the reason why we have it set up like this is because you want to be able to route your audio from one place to another. And after all this time we spent talking about routing with Pro Tools and Ableton Live and how to move your audio around, this is exactly the same. It's just that now we're dealing with it in hardware terms. Okay. Also, I want to apologize. I feel like maybe you might be able to hear that sound is coming out from outside the window. They're doing some construction. There's nothing I can do about that. Sorry. All right. So in this case here, every studio, in our case at SAE, every studio has a control room that's connected to it. So you've got the studio on one side of the glass, and you've got a control room that's connected right there to it. But we can take the audio from any studio in the building. So if I have, let's say I've got a guitar, drums, and a bass player, I'm going to record everybody at the same time. Then what I'm going to do, but I want to have them in separate rooms, what I would do is I'd put the guitar player, the drummer, and the bass player all in separate studios, and I make sure the cables are plugged into the right patch bay in the mic panel, and going into the one control room here, the audience, and everything would go in there, and we'd be good to go. So these two rooms are connected, and then this one here, the studio, comes into here. So the studio that's connected to the room that you're in, that's going to go straight into the board. The studio that's in a different place in the building, that's going to come into a patch bay. We're going to learn about patch bays later. And when it comes into the patch bay, then you have to take another cable and patch it in. Okay? So the audience has 24 channels. And if I'm using like 8 channels from this studio, those 8 channels are taken up by the studio here. And my other studio that I've got and somewhere else in the building has to come into different channels on the audience. We cannot, so let's say I'm going into channels 1 through 8 with my the studio that's right across from the audience. Well, then the second studio has to come into other channels, 9 through 16 or 16 through 24 or whatever it is, because we can't bring them into the same channel. Okay, so this is it's not too hard to see once you're in the building and you're looking at it right in front of you, but there's a little bit of you have to learn how to do it. So a lot of studios and live situations, they have what we call a snake. A snake is a group of cables that are tied together into one cable. Use them a lot, like I said, in live stages. You'll also see them in studios, and it can be any type of cable. It's not one particular type of cable that makes up a snake. It can be any type of cable. It can even be different types of cables that make up snakes. Usually those snakes will have a breakout box. Did I talk about that in here? Nope. Okay, usually these snakes will have a breakout box, and the breakout box is just a box that's at the end of the snake that you can plug all your cables into, and those can go into the console. There's also snakes that just have the cables directly, which you'll find in smaller studios. So, for example, my studio, my other studio, not this studio that I'm in right now, but my other studio at my home has I've got a couple snakes in there that I use just to connect multiple things together and bring them into one interface. So just basically, the only point of snakes really is just to be organized, just to have all your cables together and have a more tidy studio. So you just don't have, if I've got 10 cables and they're all going to basically the same place in the room, I don't have to have 10 cables all separate. I can have one snake that has 10 cables included in it, and those can all go to the same part of the room. So that's what a snake does. So you can see here, if I've got a live stage, I have my guitar, my bass, my drums, my vocals, all going into this box here in the corner, and then that box has one big giant cable that's going into the console. So different types of cables that we can use in the snake or wherever. We have an XLR. This is used mostly for microphones and powered speakers. And there are 2 parts to an XLR cable. You have the female end and you have the male end. The female end is for the input and the male end is for the output. Okay, so that's how that works there. Then you have 1/4 inch, and 1/4 inch cables are going to just be male on both ends. And then 1/4 inch comes in 2 different types. You've got TRS. TRS stands for tip, ring, sleeve. That's balanced, and it's balanced for noise reduction, so that you can cut out kind of any hum or something like that in there. And balance can also be for stereo, for headphones, or for split for a send return. And I have a little example of that down here. One end of the cable might be TRS, and then that two separate sections of the cable would go to an input and an output over here on the other end of the cable. And this is something that we use for insert effects on some mixing consoles. So for example, you learned about the Mackie 1604 in your Module 1, and that 1604 has inserts on some of the channels, and those inserts are just one cable that plugs into it to get the audio in and out of things. The 1/4" cables also have TS, which is just a tip sleeve. That's for a mono signal, and it's unbalanced as well. So TRS, most of the time in studios, that's for balanced applications. Sometimes it can also be for stereo applications, for like headphones and stuff like that. I don't have that. Well, I kind of do. I have it here. I can show you this. I just, by touching something, I just made my screen do weird stuff. Hold on a second. Let me, so it comes back. What happened? There we are. Sorry, I wiggled the wrong cable and it made the connection unstable. Sorry. What's going on here? There we go. Okay, so I just wanted to show you this here is what a TRS cable looks like. Now this is actually, I'm going to move it over to this side over here. Oh, there we go. Move it over here. So this cable here is, you can see there's tip, ring, and sleeve. TRS, 3 different parts of the cable. Okay. Sorry, it seems like I just messed up my computer by having it come unplugged. Not optimal. Sorry. All right. So a mono, unbalanced. The other type of 1/4" cable is unbalanced, and an unbalanced cable looks like, yeah, looks exactly the same. Like, let's say it looks 90% the same. Here, I've got one right here. And this is what you'll find in like guitars and stuff like that. So you can see here it doesn't have all the different rings on it. It just has one ring. That's a tip, ring, sleeve type of connection. Plug that back in over here. All right. Is it better to mix in mono or stereo? Well, that's an interesting question. Let's actually come back to that one. The answer is both. But it's kind of a question that has multiple answers to it. So let's come back to that when we talk about the audient, because we're going to get into mixing in mono versus stereo here in a little bit. All right. So we have also different connector types. We have RCA, which is unbalanced. RCA are like consumer level things, home stereos, DJ gear, stuff like that. An RCA cable, you've probably seen them. I don't think I have any really available right now. Not here. It's in like a box somewhere else. But an RCA cable is it's like the little red and white ones that you have on the back of your stereo, on the back of your speakers and stuff like that in your home like living room or whatever. You'll see them a lot for stuff like that, for boom boxes, radios, anything that normal people use. They're unbalanced, which means there's going to be more potential for noise to be introduced into the system, into the signal. So you're not going to find them on professional gear so much, although all of the Pioneer DJ gear uses RCA stuff, uses RCA connectors, but the higher end of the Pioneer CDJs and mixers also have digital inputs and outputs on them as well. Okay. So then we also have TT cables. TT cables look like small 1/4-inch cables. And then you also have a cable connection type called the D-sub. And a D-sub is one connector on one end and a group of connectors on the other end. And D-subs basically just save space. Let me see if I have the actually, you know what, here. I can show you this. There's a thing on Canvas where you can actually take a look at all these cable connector types. Let me just go over here and download it real quick. To come back to the TMS question though, is it better to mix in mono or stereo? Every mix you ever do is going to end up in stereo. All right, so that's what I meant by both, is because all your individual components for the most part are going to be mono, but the final output is always going to be stereo. So that's what I kind of meant by that. And then when you're starting off your mix, it's always, like, a lot of mix engineers recommend that you actually start your mix in mono in the beginning, just so you can hear the separation of the instruments and stuff like that. So you're kind of gonna do both, you know, as you go through things. So hold on one second, let's see here. I thought there was a, no, I guess not. I think it's got all like mixed around, so I don't see the cable thing here. Let me just check in one more place. All right, it doesn't look like it's right here. Let's see here, cables. Cable. Oh, here we go. Wait, is this it? Yes. Cool. All right. Okay, so let's just take a look at those different cables again here with pictures. Here's what a snake looks like, and you can see it's a whole bunch of cables on one end, and then on the other end is like a breakout box or something like that. It might look like this if you've got it for like on stage, like traveling around on tour or something like that. It might look a little bit more like this. You have everything in there so you can plug it all in together. We've got different connector types down here, right? The common connector types that you're going to be dealing with are your XLR. You got male and female. And that's what they would look like up close. Okay. There's more of them here. And you can see not all of these are XLRs. This one here is XLR, this one's XLR, but these are not XLR. These are DIN cables. And then here's TRS, that's what that looks like up close. And then TS, which just has a tip and a sleeve. And then balanced versus unbalanced. And the balanced signals, and again, this should all be review. The balanced signals help us to cut out some hum. They're grounded, and the unbalanced are not grounded. And then here's what RCA cables look like. In this case, here we're showing 3 cables. You've got this PDF should have been actually in Mod 1. If it's not in your Mod 1, definitely go look at it. It's called Interface Cable Review. It should have been in Mod 1, or you should have some kind of PDF like this from Mod 1. If you don't, let me know, and I'll see if I can find it in Mod 2. Right now, I don't know where it's located in Mod 2, just because of changing the order of things up for the quarantine. But I'll put it up for you later on if you don't have one. But like I said, Mod 1, you should have all this stuff, and it should be in this PDF, but maybe they changed it. Different RCA types here. Now, in this case here, you can see it's got red, white, and yellow. Red and white are for your audio left and right. Red, right is red. I always think of R for red is right, R for right, R for red, and then white is the left side. And then yellow in this case is a video connection. So yellow is going to be for our video. Usually you don't have all three of them here connected together. This is only for video applications. And I'll say it's only been they don't really use this so much anymore. So you can see this on older things, old camcorders and stuff like that, old VCRs, but you're not going to see it in modern stuff. TT cables. These stands for tiny telephone. It's known as a bantam connection, and it's used for audio and video patching. It looks like a 1/4-inch cable. They're just smaller. It's hard to see in this picture that they're smaller, but the reason why they have them so small is so that it allows you to have many connections in one small area. So that's why it's actually smaller like that. And then we have a BNC connectors used for audio, video, and clock signals here. It's got like a little thing in the middle here, and it kind of locks into place. And you have a D sub, and the D sub here has kind of like a snake, kind of. It's this cable here is what we would call the D sub, not these. These over here would be XLRs, and this here would be the D sub connector here. So anything that looks like this for audio stuff is called a D sub cable connector. Then we've got balanced versus unbalanced. Balanced, there's 3 connectors. It's got hot, cold, and ground. It's less subject to interference, and we're using it for pro connections. And you've got unbalanced, which is just 2 connectors, hot and ground. And then it's easier to pick up interference. And when I'm talking about interference, I'm talking about things like radio waves from like radio stations, or the hum from electricity, or even just the noise from electricity. And if you've never really thought about it before, but maybe you've heard this in your studio, well, that's where that's coming from. I don't know if you've ever had a situation, some of you probably have, where you've got some kind of a phantom radio sound. It's like if you've got some things connected up and you've got your speakers on, and you'll hear this like, sounds like a radio is like off in the distance. Well, that's because you have unbalanced cables that are picking up that radio interference, and if you have enough of them, you're going to hear it. I had a studio in Japan, and my studio in Florida as well. I didn't have balanced cables at those times, and I had a lot of interference coming in. So it was, pretty annoying. All right. So a couple of notes about cables. Use the shortest cable possible, especially for like guitars and things like that. Just like it's good to have a long cable because you might need it, especially when you're recording guitars and stuff like that. But if you don't need the long cable, don't use the long cable. Don't just get one extra long cable and say, well, that's good enough because it's super long. But the fact that it's super long means that there's actually more cable to pick up that interference. So you really want to have the shortest cable possible, so there's like the shortest distance between point A and point B, so it doesn't pick up the interference. Because if you have a longer cable, it's got all this space to pick up that interference, even if you're coiling it up here, and kind of especially if you're coiling it up because it's going to be right on top of its self. So especially on high impedance instruments, like I said, guitars and basses, keep the amp close to the musician, and then run a longer cable from the amp to the cabinet. Okay, so because guitars, and you're turning up the gain, you have to really kind of crank that signal up a lot. So it's more chance that you're going to pick up interference when you have a long guitar cable. But what you do is you have a shorter, you put the amp closer to the musician, and you run a shorter cable there, and then you run the longer cable from the amp or the microphone into the studio, if you can get away with that. Sometimes you can't always get away with that, and you have to kind of make do. All right, so who said... Is that question is that why my monitors make a static noise when I put my phone near it? Yes. So your monitors are basically designed to help like broadcast. They've got amplifiers in them and stuff like that. And your phone is actually interfering with that. So you put your phone near it, you're going to get a clicking sound and stuff like that. Maybe when we go to 5G, that's no longer going to be an issue. But yeah, that's why your phone is interfering with stuff. Now, if you put your phone next to your cables, you're not going to get the same kind of interference. It's a different kind of thing. But it's basically a very similar thing. So that's why you don't want to have your speakers, your phone kind of next to your speaker. It's just going to get annoying. It's not bad for anything. It's just going to get annoying. It's also why back in the day when we used to have these CRT monitors, and when I'm talking about CRT, I mean these big giant square monitors you probably have seen from movies and stuff like that. You don't see them anymore because the technology has advanced past that. But actually those old monitors, sorry, when I say monitor, I mean computer, like a display. And your speakers, if you had them right next to each other, they would also interfere with each other because of magnets and stuff like that. So pretty crazy stuff. I mean, there's a whole bunch of considerations. Let's see here, and a whole bunch of considerations that you got to think about when you're building your studio up. Okay. Also, if you can, keep your mic pre in the studio so you have a line level signal through the longer cable, if you can. But most of the time, the mic pre's are going to be in the control room. That's just kind of how most studios are set up. Grounding issues. Buzzes and hums are caused by improper groundings. This is why you have ground loops. It's an unwanted current in a conductor where both conductors should be the same potential. So you're going to get a problem there. You want to have things grounded properly so you don't get like electrical hums. There are electrical like devices and cleaners that you can buy that can help clean your sound up. Especially this will happen if you're in an older building. If you're in a building that's quite new, the electricity should be wired correctly, and also the cables are new. It should be a little bit cleaner. But if you're in an older building, and a lot of people in New York, and if you're in London, I know somebody earlier said they were in London. I don't know if they're still here or not. But a lot of old buildings, especially in these older cities with older electricity, the electrical wiring is just out of date and old and like broken, and so it has a lot more potential for getting these nasty sounds with those older buildings. So one thing you can do is you can use a ground lifter. You can use good quality cables. You can run your audio and power cables on opposite sides of your desk so the power cable is not next to the audio cables. And don't plug in your audio gear and your appliances like lights and air conditioner, stuff like that, into the same circuit if you can avoid it. We can't always avoid it, but if you can, do that. And then you can also buy some, like what they call like a power cleaner that basically cleans your electricity, supposedly. I don't ever use those, but I've talked with people who do, and they say they work. All right. Okay, we're gonna skip over here to the direct boxes. This is a DI box, direct input, and basically its main function is that it has one input, two outputs, and it can convert an unbalanced high impedance instrument level signal into a balanced low impedance microphone level signal. And it also puts out the original signal as well. It basically splits the signal. And it can also lift the ground hum caused by loops, the ground loops. So you can lift that hum out. So DI boxes, if you are having problems with hum in your recordings, maybe think about investing in a DI box, and it can help you to get rid of that hum. There are two categories of DI boxes. You have active that come in tube and solid state designs. Active DIs are basically like preamps. They usually have like a battery or phantom power, and they can drive the signal over much greater distances. So it's like a relay box. It can like boost that signal a little bit, and can lose the ground isolation, but it's good for low output instruments. Then you also have passive DIs. They're very similar to these other DIs, except for there's no power required, and when they're driven hard, it can distort in a pleasing soft way. So a good company is Whirlwind. They make a lot of different ones, types of DI boxes, and they have powered and passive. Okay, we're gonna skip over this stuff here. So here's the DI usage here. You get your bass plugged into the DI box, and then what happens is you can run a signal directly into your mixing board and also into your amp. So if you wanted to record your bass guitar directly and also record the amplified signal. What you do is you plug the bass into a DI box and run the XLR cable into your mixing desk, and then you run the 1/4 inch cable into your amplifier, and then you have a microphone to mic the amp and run that into your mixing board as well. So one thing to keep in mind if you do want to do it like this, then you have to make sure that you have 2 channels available on your mixing console, and you also have 2 channels open in Pro Tools, so you can record both of those signals simultaneously. So the person only has to play it once, and then you're recording it twice. It's the same playing, but one signal is going to be the amplified signal, and one signal is going to be the dry signal. And then you can take that dry signal, and then you can reamp that later with effects and stuff like that, like if you have amplitude or guitar rig or something like that. Line level converters. Line levels are going to take a consumer level signal and go to a professional level signal. Consumer is -10 dBV, and then professional is +4 dBu. This converter changes the consumer level into consumer and vice versa. And then it basically is what you're going to use between your consumer level and your pro level gear. If you're doing a lot of recording, for example, from record players or from like CDJs or whatever, you might want to look into getting something like this. All right, we also have digital signals. And digital signals, there's a few different types of digital cables. There's AES EBU, and it was developed by the Audio Engineering Society in the United States and also the European Broadcasting Union in Europe. And basically this is one cable. It looks like an XLR cable, but it's a bit different on the other side of things. It's not exact. You can't just take an XLR cable and use it for this. It does look like an XLR cable, but it's a bit different. And basically what happens with this is one cable can carry several channels of audio at the same time. So when we're dealing with analog, you have one cable per channel. So if it's left, you've got one cable for left, and right, one cable for right. And with digital, you can have 2 cables. So this AES EBU cable will have one channel for both left and right. Same thing with SPDIF. SPDIF stands for Sony Philips Digital Interconnect format, which is made by Sony and Philips back in the day. And essentially it's the same as AES EBU, which means that it's a stereo left and right type of thing as well. And you can also use an optical cable for this, but optical cable can also be used for ADAT, and that stands for Alesis Digital Audio Tape. And essentially we just call it ADAT, light pipe these days. This can transfer up to 8 tracks of audio on one fiber optic cable. Now that fiber optic cable, basically what that means is that it is sending light. Optic means light, right? Optical, what we can see, light. Fiber optic cable. Now you've probably heard a lot about fiber optics and stuff like that these days because of Verizon's Fios and stuff. But essentially, the fiber optic cables we're talking about here, it's basically a kind of a glass cable, which means that yes, they are more fragile than regular cables. And then it can carry 8 tracks of audio at 44.1 or 48 kilohertz. Now, if you want to record your audio at 96 kilohertz or 88.2 kilohertz, then it can only take 4 channels of audio. So it really depends on how you're recording stuff. But if you're recording stuff at 44.1, then it can take 8 channels of audio. And there's a lot of really cool uses for ADAT cables. For example, in my home studio, the way I use ADAT cables is I have a amp input box like that. It can take 8 microphones at the same time, and that has one ADAT cable that goes into the back of my audio interface, and then I can just record in like that. So it's digital. There shouldn't be any signal loss between the 2 boxes. So that's what I use my ADAT cable for. All right, so that's those. Let's go back over here to this one. And this is exactly just kind of showing what we just looked at here, except for it's just in my handwriting here. So you can see the DI box, direct input, 1 input, 2 outputs. Guitar keyboard goes in, and then go 1 to the mixer, 1 to your amplifier. And in this case, I'm also showing the microphone, and you'd see the microphone connection is right there. Digital, a couple of words that we didn't talk about just a second ago is AD converter. AD converter stands for analog to digital converter. This is going to come back a lot when we talk about the O2R desk, because the O2R is a digital console. So the AD converter changes the analog signal into digital. Once you've turned the signal into digital, try to keep that signal digital for the rest of the signal chain until you get to your speakers or your headphones, okay? Try to do that, because it's not great to keep changing the signal back and forth between analog and digital. Okay. And again, here's what I just talked about with the ADAT here, the Alesis digital audio tape. It can transmit up to 8 channels. 44.1 or 48 kilohertz can do 8 channels. 88.2 or 96 can do 4 channels. All right, so there we go. There is a lab associated with this that I do want y'all to do this week, like an exercise here. I'll put it in here because it's actually not in here right now, but basically it's super easy. What you're going to do is you're just going to write down the cables, like an example of 3 cables, and then what each cable would be used for. It's super simple, but I'll put that here in the exercise labs. I'll have to find it. It's in one of these other weeks somewhere. All right, let's do this. Let's take let's do a 5-minute break. Be back, well, a little bit over 5. Let's do a break until 10:25, because we're going to come back, we're going to talk about the audience. So let's just take a little break here so I can rest my voice for a second, and we can come back in. I'll start talking about the audience here. So we're going to be back at 10:25. So, yep.